Welcome to this production and operations management tutorial video on the weighted center of gravity technique for locating facilities. In this video, we're going to show you how to find the weighted center of gravity for a given set of demand sources. Referring to the textbook, we have a case of a company, a retailer that sells NASCAR souvenirs. And we have demand from 4 areas: Chicago, Pittsburgh, New York, and Atlanta. In this case, we're trying to locate or find the best location for a distribution center which would feed the stores in these 4 markets. And as you see in the textbook, and these are snapshots from the textbook, we have identified what the weighted center of gravity is, and we also have a graph, a chart here, a bubble chart that shows the weighted center of gravity being quite close to Pittsburgh given the demand for each of these locations. Now we're going to go and show you how to actually do these calculations. We'll begin by computing the weighted XY coordinates for each location. Then we will sum the weighted XY coordinates for all locations. We will also sum the demand for all regions, the combined demand, and then finally we will divide the sum of the weighted XY coordinates by the sum of the total demand, and that will give us our weighted XY coordinates, or the ideal location for our warehouse. Here's our given data in Excel, and to make the calculations we first want to get the weighted X coordinate. That is done simply by taking the demand and multiplying it by the X coordinate. And the weighted Y coordinate is done the same way, taking the demand and multiplying it by the Y coordinate. With these 2 formulas, we can copy them down, and it'll give us the weighted XY coordinates for each location. And then from there, we sum the X coordinate weights and the Y coordinate weights, and we also sum the demand. With this information, we're ready to calculate the weighted X coordinate and the weighted Y coordinate. The weighted X coordinate is the X coordinate weight divided by the demand, and the Y coordinate, the weighted Y coordinate, is equal to the Y coordinate weight divided by the demand again. And so this tells us on our XY chart that the ideal location for a distribution center would have the XY coordinates of 85.47 and 91.51. If we go to the next spreadsheet tab, we already have these plotted in a chart here, in this bubble chart. Now the bubble chart shows the center of gravity, the weighted center of gravity right next to Pittsburgh there, the light blue, and it also shows the respective size of each market. Again, we're selling NASCAR souvenirs, so we would expect maybe in the south that there'd be a bigger market than the cities that are up north. But now let's suppose that we were selling Chicago Cubs souvenirs in these same markets, and we want to determine where to locate our distribution center. Well, the demand in Chicago would likely be much, much higher, so instead of 600 units a month, we're going to say 6,000, and Atlanta might be substantially smaller. Maybe it's going to be 800 versus 1,800. And so now we see that the market in Chicago has gotten substantially larger, this large blue bubble, and Atlanta's gotten smaller. And we notice that the center of gravity now, based on this new demand, is much closer to Chicago. So again, it might make sense if we were selling, if we had a retailer that specialized in selling Chicago Cubs souvenirs, and we had stores in these 4 cities, probably would make sense to have a distribution center located close to Chicago. And again, our weighted center of gravity analysis bears this out, locating the center of gravity right near Chicago. Well, this is how a weighted center of gravity technique is used to help locate an ideal location for a facility. Hope this has been helpful to you and that you've been able to understand conceptually what is going on with this technique.